Right, welcome to solution to problem 9-6, utilizing a constrained resource. So we've got the Walton Toy Company. They make a line of dolls. Demand for the dolls is increasing. They want to determine an economic sales and production mix for the coming year. We've got the following information. Plant's got capacity of 130,000 direct labor hours per year. Direct labor, fixed cost, variable costs. All the company's non-manufacturing costs are fixed, okay? Company's present inventory of finished products is negligible and can be ignored. All right, so number one, determine the contribution margin per direct labor hour expended on each product. So presumably it's the workforce is the constrained resource, and that's why we're working out the contribution margin per direct labor hour. Okay, so we're going to set this up with the dolls across the top here. So we've got the Debbie, the Trish, the Sarah, the Mike, and the sewing kit. Okay. And so we have selling price $13.50, $5.50, $21, $10. Poor Mike. Oh, I can see me. Sells for more than Trish does, so that's fair enough. And $8. Okay. So there's the selling price. Now we've got variable costs as well. Direct materials, direct labor, and I don't know what it says about overhead. We'll find that in a second. Let's do direct materials. $4.30. Actually, we'll do it each doll here. Direct materials, direct labor, $3.20. And what does it say about overhead? So variable overhead is $2 per direct labor hour. Okay, how much direct labor hour do we use? We don't know yet. We got to figure that out. Okay, then let's do that. So we're going to need to leave a little bit of room here, but let's do some calculations here. So we know we have direct labor. We've got at $3.20, $2, $5.60, $4, and $1.60. Okay, so that's the direct labor cost, and direct labor is $8 per hour. So we can take the cost per unit, divide it by 8, to get the actual direct labor hours per unit, and that should be 0.4, 0.25, 0.7, 0.5, and 0.2. Okay, so if variable overhead is going to be $2 per direct labor hour, then we should be able to say, okay, $2 times 0.4 is going to be 80 cents. All right, so now looking at the Trish here, direct materials, $1.10, direct labor, $2, variable overhead, $2 times 0.25 is going to be 50 cents. Sarah, direct materials, $6.44, direct labor, $5.60, $2 times 0.7, $40. Mike, $2, $4 for direct labor, $4 times sorry, $2 times 0.5 is going to be 1. And the sewing kit, direct materials, $3.20. And direct labor, $1.60. And overhead, we've got $2 times 0.2 is going to be 40 cents. So total variable costs, let's go total VC. It's going to be, and actually if we do that, we should put an underline. There's all the separated. Okay, so total variable costs, $8.30, $3.60, $13.44, $7, and $5.20. Okay, so then we've got contribution margin now, which is really what we're driving at here, or the first half of what we're driving at anyway. So contribution margin, selling price minus variable cost. Contribution margin is $5.20, $1.90, $7.56, $3, and $2.80. Okay, so now the key decision criteria for this, if you remember, is contribution margin per unit of the constrained resource. In this case, that's direct labor hours. So contribution margin per direct labor hour, and we calculated that down here, right? Direct labor hour per unit. Okay. So $5.20 divided by 0.4 is $13. $1.90 divided by 0.25 is $7.60. $7.56 divided by 0.7 is $10.80. 3 divided by 0.5 is $6. And 280 divided by 0.2 is a whopping $14. So, what does all this tell us? At the end of the day, produce and sell as many sewing kits as you can, and then when you can't sell any more of those, switch your production to Debbie's, and when no one's buying Debbie's anymore because you've met all the demand for that, produce Sarah's next, and then Trish's, and last of all, poor Mike gets the bottom feeder in this one. Okay, now it's not like you produce that sequentially throughout the year. You don't make sewing kits from January to March and then switch to whatever. But knowing what the demand for each product is going to be is how you will adjust your production mix. But the key thing is you want to make sure that you sell as many sewing kits as possible before you sell any Deborah's and so on, right? So again, the key being sell the most profitable item on the per unit of the constrained resource basis. Okay, so that was requirement number 1. Requirement number 2, prepare a schedule showing the total direct labor hours that will be required to produce the units estimated to be sold during the coming year. Okay. And we're going to do this in order of profitability to make it easier to make decisions for us. So most profitable was the sewing kit. And then we said it was the Debbie. And then after that it was Sarah. And then after that it was Trish. And then Mike. Okay, so the sewing kit was, what did we say? Direct labor hours per unit. Sewing kit there was 0.2, and then the Debbie was 0.4, and Sarah was 0.7, Trish was 0.25, and Mike was last at 0.5. And then demand, I think somewhere in there, there we go, estimated demand for next year. So this is going to be the number of units now. So the sewing kit was 325,000. Debbie was 50,000. Sarah was 35,000. Trish was 42,000. And Mike was 40,000. So this is now going to give us the total direct labor hours for each product, right? So sewing kit, 0.2 times 325 is 65,000 direct labor hours. Debbie was 0.4 times 50,000, 20,000 hours. Sarah, 0.7 times 35, 24,500. Trish, 0.25 times 42,000 is 10,500. And Mike, 0.5 times 40,000, 20,000. So if we add all of this up, we get 140,000 direct labor hours to make all the products out there in order to satisfy the existing demand. So, number 3. Examine the data you've computed to indicate how much of each product should be made so that total production time is equal to the 130,000 labor hours available. Okay, well, clearly, if we've got demand essentially for 140,000 hours, but only 130 available, we will produce everything in order of profitability. So we're going to produce all of the sewing kits, all of the Debbies, all of the Sarahs, all of the Trishas, but only 10,000 of the Mikes. And that is what is going to have to be sacrificed because it's the least profitable per direct labor hour. So we're going to do, let's see, I'm going to say production schedule. No, just indicate how much product. Okay, so produce all sewing, Deb, Sarah, Trish, produce only 20,000 units. $10,000 direct labor hours of Mikes. Okay. 4. What is the highest price in terms of rate per hour that Walton Toy Company would be willing to pay for additional capacity? Okay. So here's where we've got to do a bit of thinking. If we can get additional capacity, how much would we want? Well, we would want 10,000 direct labor hours. What would we use with that? What would we use that 10,000 direct labor hours for? We would make Mikes, right? Because we've already met all the demand for sewing kits, Debs, Sarahs, and Trishas. So it's only Mike that we're selling, and Mike had a contribution margin per direct labor hour. No, that was a sewing kit. Where's Mike in all this mess here? Of $6. Okay, so Mike gives us a $6 per direct labor hour contribution, but that's not what the question is asking. It says what's the highest price in terms of a rate per hour that we'd be willing to pay for additional capacity. So we kind of have to take a look now at we have to look at what we're paying right now as well. And so if we go back up here, the constrained resource, so the thing we're talking about capacity now is direct labor at this $8 per hour, right? So if we're currently paying $8 an hour, we would be willing to pay the amount we're currently paying plus an amount up to our maximum contribution, $6 and no higher, would be $14. And we'll continue this in part 2 of the solution.